Now, we get rid of this thing. So, let's talk about distance, right? Since that is 70 and that is 60 degrees, right? So the total here is 70 cosine 60. Half distance here, therefore 35 cosine 60 degree, right? And that distance there is of course 70 sine 60 degree, that is centimeter, and that is also centimeter, right? So next we want to know here, we don't have to know, this one here is 5 centimeters, as the question already indicates. Therefore, when we take moment over here, we have all the distance, so let's do it. Sigma moment about point O is equal to 0, if it's in equilibrium, right? Now, if I take moment here, let's say clockwise positive, according to T, the tension, I mean, right? So, the first one we talk about is the 20. 20 pressed downwards, meaning it rotates anti-clockwise about point O against this one. So, minus 20 times the distance, 35 cosine 60 degree. The next one is the tension. Again, NW times 0, NF times 0 doesn't count. Then T rotate that way is going clockwise, so plus T. The distance, total distance here is 70 sine. That one is 5. Therefore, here in the between O and the tension force is that number minus that number. 70 sine 60 degree minus 5 in bracket equal to 0, right? Again, as I mentioned before, there is only one unknown here, which is T, the tension itself, which we want to find anyway. So if we play around with the equation, then we work out T is equal to 6.914, which is in fact 6.914. Since every force we're talking about here is kilonewton. Therefore, that one is kilonewton. Positive means we assume tension, and it's really a tension. Therefore, tension. That is, if we summarize into the answer, the tension in the rope is 6.914 kilonewton. Since we already said it's a tension, there's no need to put in tension here again, and then we can just answer it. And this is done to answer what is the tension in the rope if this stick can remain in equilibrium. Thank you very much.